Have you ever truly tried to visualize infinity? I do not mean the mathematical concept, that endless sideways figure eight we scratch onto chalkboards. I mean the physical reality of it, the sensation of a distance so vast that your mind simply refuses to process it. The human brain is a survival engine, not a cosmic simulator. It evolved to track herds on the savannah, to measure the throw of a spear, to count the seasons of a single life. We are built for the small, the tangible, the immediate. When we look up at the night sky, we feel a vague sense of awe, yes, but we are protected by our own inability to comprehend what we are seeing. If we could truly grasp the distances, the sheer, crushing scale of the silence between those points of light, I suspect we would fall to our knees, paralyzed by a vertigo so profound it would shatter our sense of self. We live in a comfortable illusion of scale, thinking that a mountain is big, that an ocean is vast, that the earth is a giant. But there are things out there in the deep dark that make our entire world, our entire history, look like a single grain of sand in an endless beach. There are monsters in the void. And today, I want to take you to meet the biggest one of them all, a structure so brutally massive, so impossibly ancient, that it defies the very rules of galaxy formation. It is a place where physics seems to have gone mad with excess, a cosmic titan that has spent billions of years devouring everything in its path to become the undisputed ruler of its corner of the universe. I am Theodore, the researcher, and this is a journey into the heart of the most brutal giant we have ever found. If you enjoy exploring the quiet, terrifying, and beautiful corners of our cosmos, please take a moment to subscribe to the channel and join our community of curious minds. It helps us keep these stories alive, and it lets me know that you are ready to leave the safety of the earth behind and drift with me into the unknown. To understand the monster, we must first understand the mouse. And in this story, the mouse is us, our home, the Milky Way. We tend to think of our galaxy as huge, and by any reasonable terrestrial standard, it is. It is a magnificent barred spiral, a pinwheel of light spinning in the dark. From one edge to the other, it measures roughly 100,000 light years. That number rolls off the tongue easily, doesn't it? 100,000. But stop for a second. Try to feel the weight of it. Light, the fastest thing in the universe, traveling at 186,000 miles every single second, takes 100,000 years just to cross our backyard. That means if you turned on a flashlight on one side of the galaxy today, the beam would not reach the other side until human civilization had risen and fallen a dozen times over. It is a distance that turns history into a blink of an eye. Within this spiral, there are somewhere between 200 billion and 400 billion stars, each one a sun, each one a nuclear furnace raging against the cold, and between them, silence, a silence so deep and so old that it feels like a physical weight. The nearest star to us, Proxima Centauri, is about 4.2 light years away. If you could shrink the sun down to the size of a grain of sand, Proxima Centauri would be another grain of sand about 4 miles away. And in between them, nothing. Just empty, vacuum-sealed darkness sprinkled with a few atoms of hydrogen per cubic meter. That is the density of our neighborhood. That is what we call crowded. We are used to things being close. We are used to the intimacy of a planet where you can fly to the other side in a day. But the universe is not intimate. It is desolate. And yet, the Milky Way, with all its billions of stars, with all its vast distances, is just a standard garden-variety galaxy. It is nothing special. It is just one of 2 trillion galaxies drifting in the observable universe. Most are smaller than us. Dwarf galaxies, irregular blobs of light that hold a few billion stars. Some are larger. The Andromeda Galaxy, our neighbor, is about 220,000 light-years across, roughly double our size. We look at Andromeda and we see a giant. We think, surely that is the limit. We think of the collision that will happen billions of years from now when Andromeda and the Milky Way crash into each other to form a new, larger elliptical galaxy. We imagine that future merger as a titanic event. And it will be. But even the combined mass of the Milky Way and Andromeda, even that future super galaxy, is nothing compared to the thing we are going to visit today. We need to travel much further out. We need to leave our local group, leave our neighborhood, and look toward the constellation of Virgo. There, deep in the heavy darkness, lies a galaxy cluster known as Abell 2029. A galaxy cluster is exactly what it sounds like, a swarm of galaxies bound together by gravity, hundreds, sometimes thousands of them, dancing around a common center of mass. Abell 2029 is about 1 billion light-years away from us. The light we see from it tonight left those stars when life on Earth was nothing but single-celled slime in the oceans. Complex life did not exist. There were no trees, no fish, no dinosaurs, just the silent, rhythmic pulse of simple biology in the water. For 1 billion years, that light has been streaming through the void, carrying the image of a monster. And at the center of Abell 2029, sitting on a gravitational throne, is the beast itself. Its name is IC 1101. The name is boring. It sounds like a license plate or a serial number on a cardboard box. It comes from the Index Catalog of Nebulae and Star Clusters, a list created in the late 19th century. But do not let the dry catalog number fool you. IC 1101 is a nightmare of scale. It is a supergiant elliptical galaxy. Unlike the Milky Way, it does not have beautiful spiral arms. It does not have a flat disk. It is a blob, a glowing golden football of stars. But football implies edges. It implies a shape you can hold. IC 1101 has no edges. It just fades. It extends outward and outward, diffusing into the darkness of the cluster, dominating everything around it. So, how big is it? When scientists first measured it, they had to check their numbers. Then, they had to check them again. They looked at the data and thought, this cannot be right. Because IC 1101 is not just bigger than the Milky Way. It is not just 10 times bigger. It is not even 20 times bigger. The Milky Way is 100,000 light-years across. IC 1101 is estimated to be somewhere between 4 million and 6 million light-years across. Let that sink in. 6 million light years. It is 60 times wider than our entire galaxy. If you placed IC 1101 exactly where the Milky Way is right now, centered on our sun, it would not just swallow us. It would swallow the entire sky. Its edge would reach past the Andromeda Galaxy. Think about that. Andromeda is 2.5 million light-years away. It is a separate island universe. To us, it is a distant smudge of light. To IC 1101, Andromeda would just be an interior decoration, a piece of furniture in the living room. IC 1101 is large enough to contain our galaxy, the Andromeda Galaxy, the Triangulum Galaxy, and every single dwarf galaxy in our local group with room to spare. It would turn our entire cosmic neighborhood, everything we have ever mapped, everything we consider local space, into a minor internal component of itself. It is not a galaxy. It is a universe in itself. But size is just a number until you fill it with something. And IC 1101 is filled with stars. The Milky Way has perhaps 400 billion stars. That is a number so large it is meaningless to the human brain. If you counted one star every second, it would take you 12,000 years to count them all. But IC 1101, it contains an estimated 100 trillion stars. 100 trillion. That is a 1 followed by 14 zeros. It has 250 times more stars than our galaxy. Imagine every grain of sand on every beach on Earth. Now imagine that every single one of those grains is a sun. That is the scale we are talking about. It is a population of stellar fire so vast that it creates a localized gravitational well deep enough to warp the fabric of space-time across millions of light years. And the terrifying thing is, most of these stars are old. They are red and yellow, ancient suns that have been burning for billions of years. There are very few new stars being born in IC 1101. It is a dying kingdom, a graveyard of stellar ambition. But why is it so big? How does something like this even happen? The universe does not usually build things this large. Gravity works, but it takes time. Gas collapses, stars form, galaxies spin up. It is a slow, elegant process. IC 1101 is not the result of elegance. It is the result of violence. It is the result of brutality. This galaxy is what astronomers call a cannibal galaxy, and it has earned that title. You see, galaxies are not static objects. They move, they flow, they interact. In a dense cluster like Able 2029, galaxies are constantly brushing up against one another. And when a large galaxy meets a small one, the outcome is inevitable. The large galaxy does not just push the small one aside, it rips it apart. Tidal forces, gravity stretching space itself, strip the smaller galaxy of its stars. It unravels the victim like a ball of yarn. The stars of the smaller galaxy are pulled out of their orbits and stream into the larger one. They are assimilated. The gas is consumed. The black holes merge. The identity of the smaller galaxy is erased completely. It becomes just more mass for the monster. IC 1101 did not grow to be 6 million light-years wide by making its own stars. It grew by eating its neighbors. It sits at the center of the cluster, the bottom of the gravitational well. Everything falls toward it. And over billions of years, it has consumed dozens, perhaps hundreds, of other galaxies. It is a graveyard of galaxies. When you look at that golden glow in the telescope images, you are not looking at a single coherent structure formed from a single cloud of gas. You are looking at the blended corpses of hundreds of ancient star systems, all mashed together into one titanic, featureless sphere. The chaos of those collisions has long since settled. The spiral arms of the victims have been destroyed, their structures smoothed out by the relentless mixing of gravity. What is left is this bloated, silent giant. It is a monument to cosmic survival of the fittest. It ate the competition, literally. And this brings us to a concept that is difficult to hold in the mind: the brutality of passive physics. We tend to personify these things. We say the galaxy is hungry, that it is violent. But the truth is colder than that. IC 1101 has no malice. It has no desire. It is simply a region where mass has accumulated to the point of absurdity. It is a pile-up on the cosmic highway that never got cleared. It is what happens when gravity wins completely and totally. The reason I call it brutal is not because it is evil, but because it is indifferent. It dominates its cluster simply by being there. Its gravity is so intense that it heats the gas in the surrounding cluster to millions of degrees, creating a glowing X-ray atmosphere that spans millions of light years. It prevents other galaxies from forming new stars by stripping away their gas. It suffocates its neighbors just by being near them. It is a suffocating presence, a king that demands absolute stillness from its subjects. Imagine standing on a planet orbiting a star deep inside icy Yellowstone. What would you see? In our sky, we see darkness. We see the black void between the stars. We see the Milky Way as a band of light, but mostly we see empty space. Inside IC 1101, the night sky would be ablaze. The average distance between stars there is much smaller than here. The sky would not be black. It would be a deep, glowing twilight, filled with thousands upon thousands of stars, brighter than Sirius, brighter than Venus. You would never know true darkness. You would be bathed in the light of 100 trillion suns. You would see no other galaxies because the stars of your own galaxy would block out the view of the universe beyond. You would think the entire cosmos was just stars, endless stars, forever. You would have no concept of the void because you would be drowning in light. It sounds beautiful, doesn't it? But there is a claustrophobia to it, a sense of being trapped in a crowded room that never ends, a room that stretches for 6 million light years. But there is something even darker at the heart of this galaxy. Every monster has a heart, and the heart of IC 1101 is a black hole. But not just any black hole. We have a supermassive black hole at the center of the Milky Way, Sagittarius A. It is about 4 million times the mass of our sun. It is a beast. It dictates the orbit of stars in our galactic core. But compared to the thing inside IC 1101, our black hole is a speck of dust. The black hole at the center of IC 1101 is one of the largest ever detected. It is estimated to be between 40 billion and 100 billion times the mass of the sun. Let's use the lower estimate, 40 billion. That is 10,000 times more massive than our own black hole. It is a hole in reality so large that its event horizon, the point of no return, would swallow our entire solar system. If you put that black hole where the sun is, the Earth would be inside it. Jupiter would be inside it. Pluto, the Voyager probes, the distant Oort cloud, all of it would be deep inside the black darkness. It would take light days to cross the diameter of the event horizon. This black hole is the engine of the brutality. It fed on the gas and the cores of the galaxies that IC 1101 consumed. It grew fat on the wreckage of collisions, and in its prime, billions of years ago, it would have been a quasar, a beacon of light brighter than the entire galaxy, blasting jets of radiation into space that sterilized anything in their path. Today, it is sleeping. It has run out of food. It sits there in the dark, a silent god in the center of a city of old stars. But its influence is still felt. The jets it fired in the past have carved out bubbles in the hot gas of the cluster, voids that are themselves millions of light years across. It has shaped its environment on a scale that makes galaxy formation look like child's play. It sculpted the cluster itself. This is the scale we are dealing with, a galaxy that eats other galaxies, a black hole that swallows solar systems for breakfast, a size that defies logic. And yet, it is there. We have the pictures. We have the data. It is a real place, made of the same atoms that make up your body and mine. It exists right now, 1 billion light years away, glowing in the Virgo darkness. And the most humbling part? It doesn't care about us. It doesn't know we exist. We are looking at it through our tiny glass lenses, measuring it with our little monkey brains, trying to fit it into our understanding of the world. And it just sits there, vast and ancient, enduring. It has survived for billions of years, and it will survive for billions more, long after our sun has burned out and the earth is a cold, dead rock. In the next chapter, We are going to dive deeper into exactly how this monster was found, because the story of its discovery is almost as strange as the galaxy itself. It was hiding in plain sight, a giant disguised as a smudge, waiting for humanity to build eyes sharp enough to see it for what it truly was. We will walk through the history, look at the serendipity of science, and realize just how close we came to missing it entirely. The history of human discovery is often painted as a series of triumphs, a parade of eureka moments where genius illuminates the dark. But if you look closer, truly look at the timeline of how we figured out our place in the universe, you see something different. You see that discovery is mostly a history of blindness. It is a history of looking directly at the truth and failing to recognize it because our minds simply were not ready to hold the scale of what we were seeing. We stumble in the dark, bumping into giants, and for centuries we convince ourselves they are just shadows. The story of IC 1101 is the perfect example of this cosmic myopia. It is a story about how the largest object in the universe was dismissed as a smudge, a piece of dust on the lens of our understanding for over 200 years. It sat there, glowing with the light of 100 trillion stars, screaming its existence across the void. And we looked at it and said, "It is just a cloud." This chapter is about that blindness and the terrifying moment when our eyes finally opened. I am Theodore, the researcher, and if you are new here, we are dissecting the most massive galaxy ever found, a structure that challenges the very laws of physics. If you want to understand the monsters that live in the deep universe, make sure you are subscribed. Let us continue our descent. To understand how we missed the monster, we have to go back to a time before electric lights, before computers, before we even knew what a galaxy was. We have to go back to the night of June 19th, 1790. The world was a smaller place then. The French Revolution was in full swing, creating chaos in Europe. The United States was a newborn nation. And in England, a German-born musician turned astronomer named William Herschel was doing what he did every clear night. He was hunting. Herschel was not a professional scientist in the modern sense. He was an obsessive. He built his own telescopes, grinding the metal mirrors by hand, polishing them for hours until his arms ached, creating instruments that were superior to anything the Royal Observatory possessed. He was mapping the sky, systematically sweeping the heavens to catalog every nebulous object he could find. On that night in June, he pointed his telescope toward the constellation Virgo. His instrument was a reflector with a focal length of 20 feet, a wooden beast that he had to manipulate with ropes and pulleys. It was the most advanced technology of its day, a light bucket designed to capture the faintest whispers of the cosmos. As he scanned the darkness, something caught his eye. A faint, fuzzy blob. It was not a star. It did not resolve into a sharp point of light. It was diffuse, misty. He stopped the sweep, adjusted his focus, and stared at it. In his logbook, he recorded it simply. He noted its position. He noted its appearance. He gave it a number. And then he moved on. He had to. There was so much sky to cover. Herschel had no way of knowing what he had just seen. To him, and to every other astronomer of the 18th century, the Milky Way was the universe. They believed that all the stars, all the planets, and all the nebulae, those fuzzy patches of light, were contained within our own galactic system. When Herschel looked at IC 1101, he thought he was looking at a small cloud of gas, perhaps a stellar nursery or a dying star's envelope, located relatively close to us, maybe a few thousand light years away. He looked at a city of 100 trillion stars. an object 6 million light-years wide, and he mistook it for a puff of smoke in his own backyard. It is a staggering error of scale. It is like looking at a mountain range on the horizon and thinking it is a crumpled napkin on the table in front of you. But we cannot blame him. The concept of other galaxies did not exist. The human mind had not yet stretched far enough to contain the idea of an island universe. For the next century, that faint smudge remained just another entry in the catalog. It was eventually designated IC 1101 in the index catalog, a dry list of thousands of similar objects. It sat in the books, gathering dust, ignored by almost everyone. It was a sleeper agent of cosmic horror, waiting for the technology to catch up with its reality. The revelation did not come until the 20th century, when humanity finally developed the tools to measure the unmeasurable, the distance to the stars. The key was light, specifically the stretching of light. As the universe expands, it pulls light waves apart. A wave of blue light, traveling through the expanding fabric of space for billions of years, gets stretched out until it looks red. This is called redshift. The faster an object is moving away from us, and the farther away it is, the redder its light becomes. In the early 1900s, astronomers like Vesto Slipher and Edwin Hubble began analyzing the light from these spiral nebulae. They passed the light through prisms, breaking it down into rainbows called spectra, and what they saw shocked them. The light from these objects was shifted toward the red end of the spectrum by impossible amounts. They were not just moving, they were fleeing. They were rushing away from us at speeds that made no sense if they were inside the Milky Way. Hubble put the pieces together. He realized that these nebulae were not clouds of gas nearby. They were entire galaxies, millions of light years away. The universe suddenly exploded in size. The boundaries of reality were pushed back, shattering the cozy little celestial sphere we thought we lived in. And when they finally turned these new techniques on the boring, faint blob known as IC 1101, the numbers came back, and they were terrifying. The redshift measured was 0.0779. To a layman, that number means nothing. To an astrophysicist, it means a distance of approximately 1.4 billion light years. 1 billion light years. The moment that number was calculated, the true nature of the beast was revealed. If something appears as a visible smudge in a telescope from a billion light years away, it cannot be a cloud. It cannot be a normal star cluster. For us to see it at all across that abyss, it has to be titanic. It has to be emitting an amount of light that defies comprehension. The small cloud Herschel saw was instantly transformed into the largest single structure in the known universe. It was a paradigm shift that makes your stomach drop. It forces you to reevaluate everything. It means that for 200 years we had been looking at the king of the cosmos and treating it like a peasant. But there is a deeper layer to this discovery, one that I find haunting. When we say IC 1101 is a billion light years away, we are not just talking about distance. We are talking about time. We are talking about archaeology. In astronomy, looking out is looking back. The speed of light is fast, but it is finite. It takes time for photons to travel across the void. The image of IC 1101 that hits the mirror of the Hubble Space Telescope today is not the galaxy as it is now. It is the galaxy as it was 1 billion years ago. We are looking at a ghost. We are looking at a fossil made of light. Think about what was happening on Earth when the light falling into our telescopes today first left the surface of those distant stars in IC 1101, it was the Proterozoic eon. 1 billion years ago, the continents were unrecognizable, mashed together in a supercontinent called Rodinia. There were no animals on land, no plants, no insects. The silence on Earth was absolute, broken only by the wind and the crashing of waves on barren, rocky shores. The oceans were slime green, filled with stromatolites and microbial mats. Life was microscopic, struggling to gain a foothold. That is the world that existed when the photons of light launched themselves from the stars of IC 1101. For 1 billion years, that light traveled. It flew through the empty spaces between galaxies in the Abel 2029 cluster. It crossed the vast cold voids of the cosmic web. While that light was in transit, complex life exploded on Earth. The Cambrian explosion filled the seas with monsters. Plants colonized the land. Fish learned to walk. The dinosaurs rose, ruled the planet for 150 million years, and were wiped out by an asteroid. Mammals scurried in the ashes. Primates stood up. Humans discovered fire, invented the wheel, built pyramids, waged wars, split the atom, and launched telescopes into orbit. All of human history, every love story, every war, every song ever sung, happened while that beam of light was silently crossing the dark. And only now, in our brief moment of technological capability, has it arrived to tell us that the monster exists. This time, delay creates a strange sense of melancholy. We can never know what IC 1101 is doing right now. We can only know what it used to be. For all we know, in the 1 billion years since that light left, the galaxy could have collided with another giant. It could have been disrupted. Its stars could have burned out. The now of IC 1101 is forever locked away from us, hidden behind the insurmountable wall of the speed of light. We are separated from it, not just by space, but by causality itself. We are watching a movie that ended 1 billion years ago, and we are only just seeing the opening credits. But even with this delay, modern technology has allowed us to peel back the layers of this giant. The launch of the Hubble Space Telescope in 1990, exactly 200 years after Herschel's discovery, changed everything. Free from the blurring effects of Earth's atmosphere, Hubble could peer into the core of IC 1101, and what it found was confusing. Usually the center of a galaxy is dense with stars, getting brighter and brighter until it hits a peak. But the core of IC 1101 is diffuse. It is huge, yes. The core alone is 14,000 light-years across, which is bigger than most dwarf galaxies, but it is flat. The stars are scattered. It looks like a bomb went off inside it. This scoured core is the smoking gun of its violent history. It is the evidence that leads us to the theory of the supermassive black hole binaries. When IC 1101 ate other galaxies, their black holes did not just disappear. They sank to the center. They found the original black hole of IC 1101 and began to orbit it. You had binary black holes, billions of times the mass of the sun, dancing around each other in the heart of the galaxy. As they swung past each other, their gravity acted like a slingshot. They kicked the nearby stars out of the core, flinging them into high orbits or ejecting them from the galaxy entirely. The black holes acted like a whisk, stirring the center and emptying it of stars. This process, called core scouring, suggests that IC 1101 is not just a cannibal. It is a serial merger. It has done this over and over again. It has swallowed black holes, used them to scour its own heart, and then merged with them to grow even larger. The technology we use to study this, X-ray observatories like Chandra, infrared telescopes like James Webb, reveals a galaxy that is embedded in a halo of dark matter so massive It defies belief. The visible galaxy, the stars we can see, is just the tip of the iceberg. The dark matter halo of IC 1101 is estimated to weigh trillions of solar masses. It is a gravitational anchor that holds the entire galaxy cluster together. We cannot see dark matter. It does not emit light. It does not reflect light. It is a ghost substance that interacts with our world only through gravity. But we know it is there because of how the stars move. They are moving too fast. If only the visible stars were providing the gravity, IC 1101 would fly apart. It would dissolve. The fact that it holds together means there is an invisible skeleton, a scaffolding of dark matter that gives the monster its shape. So here we stand, at the end of the history of discovery. We have gone from Herschel's faint, fuzzy blob to a detailed understanding of a hypergiant elliptical galaxy, powered by the largest black hole we know of, held together by dark matter and seen through the lens of 1 billion years of time travel. It is a triumph of science, but it is also a warning. It warns us that our senses are not to be trusted. It warns us that the universe is not obligated to be intuitive. It warns us that there are things hiding in the dark that are bigger than our imagination can handle. In the next chapter, we are going to leave the history books behind and go back into the physics. We are going to look at the process of galactic cannibalism in detail. How exactly does a galaxy eat another galaxy? What does it look like when two spiral galaxies, beautiful and orderly, are smashed together to form a chaotic elliptical blob? We will explore the violence of the merger, the starbursts, and the death of structure. We will see how beauty is destroyed to create size. And we will ask the question, is our own Milky Way destined for the same fate? When we look at a picture of a galaxy, we see something serene. We see a static island of light floating in the black velvet of space. It looks peaceful, almost eternal, like a painting that has hung on a museum wall for centuries. But this stillness is a lie. It is a trick of scale and time. If we could press a fast-forward button on the universe, compressing millions of years into seconds, that serene painting would dissolve into a scene of absolute carnage. The universe is not a museum. It is a slaughterhouse. It is a place where gravity is a relentless, hungry force that does not respect boundaries, structure, or beauty. The story of IC 1101, the monster we are exploring, is not a story of peaceful growth. It is a story of consumption. It is a story of galactic cannibalism. And to understand the beast, we have to understand the violence that built it. We have to look at the mechanics of how one galaxy eats another and realize that this same violence is happening right now in our own backyard, to the very galaxy we call home. I am Theodore, the researcher, and we are peeling back the skin of the universe to see the muscles and bones underneath. This is Chapter 3 of our deep dive into the largest galaxy ever discovered. If you want to understand the true, often terrifying nature of the cosmos we live in, please make sure you are subscribed to the channel. Join us as we drift deeper into the dark, because the things we find there will change the way you look at the night sky forever. Galactic cannibalism begins long before two galaxies actually touch. It begins with a dance. Gravity is an infinite force. Its reach has no limit, though it weakens with distance. In a crowded environment like the Abel 2029 cluster, galaxies are constantly feeling the gravitational tug of their neighbors. Imagine two galaxies drifting toward each other. They might be millions of light years apart, but they are already locked in a fatal embrace. As they close the distance, the first thing that happens is distortion. Gravity does not pull on everything equally. The side of a galaxy facing its partner feels a stronger pull than the far side. This differential pull is what we call a tidal force. It is the same force that the moon uses to pull the oceans of Earth, but on a galactic scale. It does not just move water. It moves stars. If you were watching this encounter speed up, you would see the galaxies start to stretch. They warp. They elongate. It looks like taffy being pulled apart by invisible hands. The beautiful, orderly spirals of a galaxy are distorted into long, twisted shapes. Stars that have spent billions of years orbiting peacefully in the disk are suddenly ripped from their paths. They are flung outward into the void, creating massive streamers of light called tidal tails. These tails can stretch for hundreds of thousands of light years, ghostly ribbons of stolen stars that mark the trajectory of the doomed. It is a scene of slow-motion disintegration. The smaller galaxy, the victim, is literally unraveled. Its structure is stripped away, layer by layer, until its core is exposed, naked and vulnerable, to the waiting maw of the larger galaxy. But the violence is not just gravitational. It is physical. Galaxies are not just made of stars. They are filled with gas and dust, the raw materials of creation. When two galaxies collide, their stars almost never hit each other. The distances between stars are too vast. They pass through the empty spaces like ghosts passing through a wall. But the gas clouds are huge, extending for light years, and they crash into each other with the force of 1 billion hurricanes. This collision creates shock waves that ripple through the interstellar medium, compressing the gas, heating it, and triggering a catastrophic event known as a starburst. A starburst is exactly what it sounds like. It is a frenzy of birth. The compression of gas triggers gravity to take over, collapsing clouds into new stars at a rate that is hundreds, sometimes thousands of times faster than normal. For a brief moment in cosmic time, the merging galaxies light up like a torch. They blaze with the blue-white fire of newborn suns, outshining everything else in their cluster. It looks like a celebration, a fireworks display of creation. But in reality, it is a death throw. This furious burst of star formation burns through the galaxy's fuel supply in a geological instant. The gas that should have sustained the galaxy for billions of years is used up in a single party. It is a use it or lose it scenario. The merger forces the galaxy to spend its inheritance all at once, leaving it bankrupt for the future. This is the process that built IC 1101. But IC 1101 did not just do this once. It did not just have a fling with a neighbor and settle down. It is a serial killer. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its lifetime. 76 times another substantial galaxy, perhaps the size of the Milky Way or larger, fell into its gravity well and was obliterated. 76 times the structure of a victim was torn apart, its stars scattered, its gas consumed or blown away. And that is just the major meals. It has likely consumed countless dwarf galaxies, snacks that barely registered on the scale of its appetite. The evidence of this gluttony is written in the shape of IC 1101 itself. Most galaxies in the nearby universe are spirals like the Milky Way. They are flat disks with beautiful arms, rotating in an orderly fashion. Spiral galaxies are delicate. They require a quiet life to maintain their structure. If you smash two spiral galaxies together, the delicate balance is destroyed. The orbits of the stars are scrambled. They stop moving in a nice flat plane and start moving in random directions like a swarm of angry bees. The resulting shape is not a disk, it is a blob, a sphere, or an ellipsoid. This is why IC 1101 is an elliptical galaxy. It is a smooth, featureless ball of stars because it is a mess. It is the result of so many collisions that all structure, all order, all uniqueness has been averaged out into a giant golden fog. Think about the tragedy of that. 76 unique galaxies, 76 island universes, each with its own history, its own spiral arms, its own specific chemistry. Perhaps they had civilizations. Perhaps there were eyes looking up from planets in those galaxies, mapping their own Milky Ways, naming their own constellations. And then gravity took hold. The sky changed. A monster approached, and over the course of a few 100 million years, their entire reality was shredded, mixed, and absorbed into the collective. Their identity was erased. Now, they are just nameless stars orbiting in the halo of IC 1101, lost in the crowd of 100 trillion others. It is the ultimate erasure of history. The monster remembers nothing of what it ate. It just grows. But we should not get too comfortable judging IC 1101 from our high horse. We look at it with horror, calling it a cannibal, a brute. But the uncomfortable truth is that we are looking in a mirror. Our own galaxy, the Milky Way, is a cannibal too. It is just a quieter one. Right now, as you read this, the Milky Way is in the process of digesting several smaller galaxies. The Canis Major dwarf galaxy is currently being ripped apart by our gravity, its stars added to our own disk. The Sagittarius dwarf elliptical galaxy is looping around us, getting stretched into a long stream of stars that wraps around the Milky Way like a ribbon. We see these stellar streams in our sky, the ghostly remains of our victims. We are built on the bones of the dwarfs we have consumed, and the violence is not over for us. We have a date with destiny, and her name is Andromeda. The Andromeda galaxy is the largest member of our local group. It is heading toward us at about 68 miles per second. For a long time, scientists were certain that a collision was inevitable in about 4 billion years. Recent studies have introduced some uncertainty. There is a chance it might be a glancing blow or a miss, depending on the influence of other galaxies like the Triangulum. But if it does happen, it will be the end of the Milky Way as we know it. Imagine looking up at the sky in 4 billion years. Andromeda would not be a small smudge. It would dominate the night. It would look like a second Milky Way, growing larger and larger until it filled the entire view. As the galaxies interact, the sky would be distorted. The band of the Milky Way would be twisted. New stars would burst into life, creating nebulae of unimaginable brightness. And then the structure would fail. The sun would be flung into a new orbit, perhaps exiled to the outer halo, or perhaps sent diving into the core. The two supermassive black holes would spiral together and merge. And when the dust settled, billions of years later, there would be no Milky Way. There would be no Andromeda. There would only be Milkomeda, a giant elliptical galaxy, a smooth, featureless blob, a mini version of IC 1101. This is the fate of all large structures in the universe. Gravity loves a sphere. It hates complexity. It wants to pull everything down to the lowest energy state, to the most compact form. The beautiful spirals we see today are just a phase. They are the adolescence of the universe. The future belongs to the ellipticals. The future belongs to the monsters. IC 1101 is just ahead of the curve. It has reached the endpoint of galactic evolution sooner than the rest of us, because it lives in a crowded city while we live in the suburbs. It shows us our own future writ large. It shows us that, in the end, everything merges. Everything becomes one. But there is a cost to this growth, a terrible cost. I mentioned the starbursts, the fireworks of star formation that happen during a merger. That sounds like a good thing. New stars, new planets, new chances for life. But it is a trap. By using up all the gas in these bursts, the galaxy sterilizes itself. Gas is the lifeblood of a galaxy. It is the fuel for future generations of stars. When a galaxy like IC 1101 eats its neighbors and triggers these massive starbursts, it burns through its savings account. It consumes the gas or heats it up so much that it cannot cool down to form stars anymore. This is why IC 1101 is a red and dead galaxy. The blue stars, the big, hot, young ones, die young. They explode as supernovae. What is left are the red dwarfs and yellow suns, the old stars that burn slowly. Since there is no gas left to make new blue stars, the galaxy slowly turns red. It stops evolving. It stops creating. It enters a long, slow decline toward heat death. IC 1101 is enormous, yes. It is the king of the cluster. But it is a king sitting on a throne of ash. It traded its vitality for size. It traded its future for domination. The mechanism that ensures this sterility is the black hole we discussed in the first chapter. The monster in the middle. You might think a black hole just eats, but it also speaks. It screams energy back into the galaxy. When gas tries to fall into the center to form new stars, the black hole wakes up. It blasts jets of particles at nearly the speed of light. It heats the surrounding gas, blowing huge bubbles in the cluster atmosphere. We see these bubbles in X-ray images, cavities millions of light years across. This is called active galactic nucleus feedback, or AGN feedback. It is the galaxy's way of choking itself. The black hole acts like a thermostat. If the galaxy tries to make stars, the black hole heats the gas and stops it. It keeps the galaxy dead. It ensures that the monster stays in its grave, even as it continues to reign. So, when we look at IC 1101, we are looking at a completed work. The painting is finished. The artist has put down the brush. There will be no new strokes, only the slow fading of the colors over eons. It is a monument to a violent past, frozen in a silent present. It is a warning that bigger is not always better. Sometimes bigger just means older, colder, and lonelier. In the next chapter, we are going to shift our perspective from the galaxy itself to the environment it lives in. We are going to explore the cluster in more detail, the Abel 2029 cluster. We will look at the hot gas that fills the space between the galaxies, the intra-cluster medium, and understand how IC 1101 sits at the center of a web of dark matter. We will explore the concept of the cosmic web and how the largest structures in the universe are connected. And we will ask, if gravity is pulling everything together, what is pushing it apart? We will introduce the antagonist that will eventually kill even this giant. Dark energy. We are taught from a young age that space is a vacuum. We are told it is an empty, cold void where nothing exists between the stars and the planets. We imagine galaxies as lonely islands of light drifting on a sea of absolute nothingness, separated by chasms of silence. But this is one of the greatest misconceptions in astronomy. The space between galaxies is not empty, it is not cold, and it is certainly not silent. If you had eyes that could see in the X-ray spectrum, the dark spaces between the stars of the Abel 2029 cluster would not be black at all. They would be glowing with a ferocious, blinding intensity. The monster galaxy, IC 1101, does not sit in a vacuum. It sits in a bath of superheated plasma, a cosmic soup so hot and so massive that it challenges our definition of what a galaxy really is. To understand the beast, we have to look at the cage it lives in. We have to look at the invisible skeleton of the universe that traps it there. And we have to confront the terrifying tug-of-war between two invisible titans, dark matter and dark energy, that will decide the fate of this giant and everything else in existence. I am Theodore, the researcher, and we are continuing our journey into the most extreme environment in the cosmos. We are moving from the visible monster to the invisible forces that control it. If you want to see the universe not just as a collection of pictures, but as a living, breathing, and sometimes dying machine, please subscribe to the channel. Let us peel back the layer of visible light and see the universe as it truly is. When astronomers look at the Abell 2029 cluster, the home of our monster, they see something that looks like a swarm of bees frozen in amber. It contains thousands of galaxies all bound together by gravity. But these galaxies are just the croutons in the salad. The real substance of the cluster, the thing that dominates it by mass, excluding dark matter for a moment, is the intracluster medium. This is a fancy name for gas, but it is not the cool, wispy clouds we see in pictures of nebulae. This is gas that has been heated to tens of millions of degrees. It is so hot that the atoms have been stripped of their electrons, turning it into a plasma that screams in X-rays. Where did this heat come from? It came from gravity. As the cluster formed over billions of years, gas fell into the gravitational well. As it fell, it accelerated. It crashed into other gas streams. The kinetic energy of that fall was converted into heat. It is the same principle that makes a meteor burn up in Earth's atmosphere, but on a scale of millions of light years. The gravity of the cluster is so crushing that it keeps this gas in a permanent state of fever. This atmosphere of the cluster contains more mass than all the stars in all the galaxies of the cluster combined. Think about that. If you added up every star in IC 1101 and every star in every other galaxy in the cluster, they would still be outweighed by the invisible, scorching gas filling the spaces between them. IC 1101 is drowning in this ocean of fire. This environment explains why IC 1101 is where it is. Abell 2029 is what astronomers call a relaxed cluster. This does not mean it is chilling out on a beach. It means it has had time to settle down. It has reached a state of equilibrium. In a young, chaotic cluster, galaxies are zooming around everywhere. But over billions of years, a process called dynamical friction takes over. As a massive galaxy moves through the sea of smaller galaxies and dark matter, it creates a wake behind it. The gravity of the objects it passes pulls backward on it, slowing it down. It is like trying to run through water. You lose energy. And when an orbiting object loses energy, it sinks. This is the relentless destiny of the heavy. The biggest galaxies sink to the bottom of the gravitational well. They drift toward the center. IC 1101 is the heaviest object in the cluster, so it sits exactly at the center. It is the drain at the bottom of the bathtub. Everything that sinks eventually meets it. This is why it grew so large. It did not have to hunt for food. The food was delivered to it by the laws of physics. It sits at the point of maximum density, the crossroads where all paths eventually meet. It is the inevitable destination of everything in its neighborhood, but gravity requires mass. And when scientists counted up all the stars in IC 1101 and even added in all the hot gas, the numbers did not make sense. The galaxies were moving too fast. The gas was too hot. If the only things holding the cluster together were the visible matter, the stars and the gas, the whole thing should have flown apart, billions of years ago. The gravity of the visible stuff is simply not strong enough to hold on to gas that is moving at such high speeds. There had to be something else, something heavy, something invisible. This brings us to the true ruler of IC 1101, dark matter. We tend to think of the galaxy as the glowing ball of stars, but that is just the tip of the iceberg. The visible galaxy, enormous as it is at 6 million light-years wide, is embedded in a halo of dark matter that is even larger. This halo extends out for tens of millions of light-years. It is a vast, invisible sphere of unknown particles that outweighs the visible galaxy by a factor of nearly 100. The total mass of IC 1101, including this dark sector, is estimated to be over 1 quadrillion solar masses. That is 1,000 trillion suns. This dark matter halo is the skeleton of the galaxy. It is the scaffolding that allows the stars to exist. Without it, IC 1101 would dissolve. The stars would drift away into the void. We are looking at a structure that is 90% ghost. We do not know what dark matter is. We have never caught a particle of it in a lab. We only know it exists because we can see its shadow. We can see how its gravity bends light and pulls on stars. In the case of IC 1101, the dark matter is so dense that it acts as a gravitational lens, bending the light of galaxies behind it, magnifying them like a cosmic telescope. It is a humiliating realization for us. We spend all our time studying the stars, the light, the baryonic matter that makes up you and me. But we are the minority. We are the foam on the ocean. The universe is made of darkness, and IC 1101 is one of the greatest concentrations of that darkness in existence. Now, let us zoom out even further. If IC 1101 is a node, what is it connected to? The universe is not a random scattering of galaxies. It has a structure. It looks like a sponge, or a spider web, or the neurons of a brain. This is called the cosmic web. Long filaments of dark matter and gas stretch across the universe for hundreds of millions of light years. Galaxies grow along these filaments like dewdrops on a spider's silk. Where the filaments cross, where the web is thickest, you get massive clusters like Abel 2029. IC 1101 sits at the heart of one of these great intersections. It is a nexus point. Matter flows along the filaments, rivers of gas and galaxies streaming through the void, pouring into the cluster, and eventually spiraling down into the waiting mouth of the giant. It is a feeding system that spans the cosmos. This hierarchical structure, small things merging to make big things, flowing along the web to the centers of gravity, is the fundamental building block of our cosmology. It explains how a monster like this can exist. It is the ultimate beneficiary of a supply chain that covers a significant fraction of the observable universe. But there is a twist in this story, a plot twist that turns this tale of triumph into a tragedy. For billions of years, gravity has been the winner. It pulled the gas together. It built the web. It created the cluster. It forged the giant. But gravity is not the only player in the game. There is another force, one that we discovered only recently, and it is the mortal enemy of structure. It is the antagonist of our story. Its name is dark energy. In 1998, astronomers studying distant supernovae made a discovery that broke physics. They found that the expansion of the universe was not slowing down, as everyone expected. It was speeding up. Some mysterious force was pushing space apart, acting as a kind of anti-gravity. We called it dark energy, a placeholder name for our ignorance. Dark energy makes up about 68% of the total energy of the universe, and unlike gravity, which pulls things together, dark energy tears them apart. This creates a cosmic tension. Inside the Obel 2029 cluster, gravity is still strong enough to hold things together. The density of dark matter and gas is high enough that IC 1101 is safe for now. But outside the cluster, dark energy is winning. The space between galaxy clusters is expanding faster and faster. The filaments of the cosmic web are being stretched thin. The supply lines are being cut. This means that IC 1101 has reached its peak. It has eaten everything that was close enough to be eaten. The galaxies that are currently falling in are the last generation of victims. The galaxies further out, the ones that might have fed the monster in the distant future, are being carried away by the expansion of the universe. They are moving away from IC 1101 faster than they can fall toward it. The horizon is shrinking. The universe is breaking up into isolated islands. Imagine living in a city where the roads leading out of town are being stretched. The cars coming toward you are getting slower and slower until they stop and start moving backward. The suburbs disappear. The neighboring cities fade into the mist. Eventually, your city is the only thing left in the world. That is the future of IC 1101. It will become an island universe in the truest sense. As the billions of years roll by, the other galaxy clusters will vanish from its sky. They will cross the cosmic event horizon, moving away faster than light can travel, and disappear forever. The observers of the far future, living on a planet around a red dwarf star in IC 1101, will look up and see a sky filled with their own galaxy's stars. But if they look beyond, they will see nothing. Absolute blackness, no other galaxies, no cosmic web, no evidence of the Big Bang. They will think that their galaxy is the entire universe, eternal and static. They will have no way of knowing about the trillions of other galaxies that once existed, because the light from those galaxies can no longer reach them. Dark energy will have erased the rest of the cosmos from their view. IC 1101 is a monument to a time when the universe was connected. It is a relic of the era of mergers. But that era is ending. We are living in the peak of cosmic structure. From here on out, the universe gets lonelier, the void gets bigger, the giants get isolated. IC 1101 is a king that has conquered the world, only to find that the world is crumbling away beneath its feet. It will rule over a kingdom of one, floating in an ever-expanding darkness that will eventually separate every atom from every other atom. But before that final darkness falls, there is still a long, slow decline to endure. In the next chapter, we are going to look at the death of the stars. We know that IC 1101 is already red and dead, but what does the future actually look like for those 100 trillion stars? We will explore the era of the red dwarfs, the long twilight of the universe, and the strange, degenerate objects that will be the last survivors in the galactic graveyard. We will walk through the timeline of the end, from the death of the last sun-like star to the freezing of the last white dwarf. We live in the age of light. When we look up at the night sky, we are seeing the universe in its exuberant youth. It is a time of flashy energy, where hydrogen is cheap, gas is plentiful, and galaxies are lit by the brilliant, wasteful fires of massive blue stars. We take this brilliance for granted. We assume that the stars are eternal, that the sun will always rise, that the galaxy will always glow. But this era of starlight is a fleeting anomaly. It is a brief spark in the dark history of time, a momentary flashbulb popping in a vast, cold cathedral. IC 1101, the monster galaxy we have been exploring, is a window into the future of this light. It is a glimpse of the end. While the Milky Way is still partying, churning out new stars in its spiral arms, IC 1101 has already left the party. It has entered the long, slow twilight of the cosmos. This chapter is about that twilight. It is about the slow, suffocating death of 100 trillion stars and the transformation of a golden giant into a ghost. I am Theodore, the researcher, and we are now moving beyond the present day, projecting our minds into the deep future to witness the fate that awaits the largest object in the universe. If you are ready to confront the ultimate destiny of all things, including ourselves, please subscribe to the channel. Let us walk together into the dying light. To understand the death of IC 1101, you first have to understand the demographics of its population. In the Milky Way, we have a mix of stars. We have massive, hot blue stars that live fast and die young, exploding as supernova K after only a few million years. These are the rock stars of the galaxy, shouting their energy into the void. But in IC 1101, the rock stars are all dead. They burned out billions of years ago. The galaxy has run out of the gas needed to make new ones. What is left is the middle class and the working class of the stellar world. The galaxy is dominated by yellow stars like our sun, and overwhelmingly by red dwarfs. This gives IC 1101 its characteristic golden yellow hue. It is the color of age. It is the color of a fire that is burned down to the embers. Let us look at the fate of the sun-like stars first. There are billions of them in IC 1101, ancient siblings to our own sun. These stars have lifetimes of about 10 billion years. Many of them are already approaching their end. As they exhaust the hydrogen in their cores, they will not explode. They will swell. They will turn into red giants, expanding outward until they swallow their inner planets. For a brief moment, perhaps 100 million years, which is nothing on cosmic scales, they will shine with a desperate, bloated intensity. Then they will shed their outer layers. They will puff off their atmospheres into space, creating beautiful shells of glowing gas called planetary nebulae. Imagine the view from inside IC 1101 during this epoch. The sky would be filled with these glowing multicolored clouds, the final breaths of dying solar systems. It would be a time of haunting beauty, a funeral procession of billions of stars. But the beauty is transient. The gas will dissipate into the intergalactic void. What remains at the center of the nebula is a white dwarf, a core of carbon and oxygen, packed as dense as a diamond, no larger than the Earth, but containing the mass of a sun. These white dwarfs do not produce energy. They do not fuse atoms. They simply sit there, radiating away their stored heat, slowly cooling down over eons. They are stellar corpses, and IC 1101 is filling up with them. Every day, more suns die and are replaced by these cooling tombstones. But the true survivors, the ones that will keep the lights on in IC 1101 long after the sun-like stars are gone, are the red dwarfs. These are tiny stars with perhaps only 8% to 50% of the mass of the sun. Because they are small, they sip their fuel rather than gulping it. They are incredibly efficient. A red dwarf born today will still be shining trillions of years from now. They will outlive the current age of the universe by a factor of thousands. In the deep future, IC 1101 will be a galaxy of red dwarfs. The bright yellow glow we see today will fade to a deep, dim crimson. This red era will last for a time that defies comprehension. But even the red dwarfs are not immortal. Physics comes for everyone eventually. One by one, over trillions of years, these tiny stars will exhaust their hydrogen. They will not swell into giants. They do not have the mass for that. They will simply get hotter and bluer for a brief period as they compress, and then they too will collapse into white dwarfs. Scientists estimate that the last star in the universe will be born around 100 trillion years from now. By that time, the gas and dust needed for star formation will have been completely used up or dispersed so thinly that gravity can no longer pull it together. The era of starlight will officially end. When that happens, IC 1101 will change. It will no longer be a living galaxy. It will be a graveyard. It will be a collection of 100 trillion stellar remnants, white dwarfs, neutron stars, and black holes, orbiting in the dark. The visual transformation will be terrifying. Today, IC 1101 is a beacon visible across 1 billion light years. In the degenerate era, it will be invisible to the naked eye. If you were floating in the space nearby, you would see nothing. You would have to use infrared goggles to see the faint, dying heat of the white dwarfs. The monster will have become a ghost. It will still have its mass. It will still have its gravity. The dark matter halo will still be there, but the light will be gone. There is a specific kind of horror in this slow fade. It is not a violent apocalypse. It is not a bang. It is a whimper. It is the universe slowly running down like a clockwork toy that has lost its key. Entropy is the ultimate predator. It eats energy. It eats structure. And in the case of IC 1101, it is eating the very concept of a galaxy as a luminous object. But the story does not end with the death of the stars. In fact, in terms of timescales, the era of stars is just the blink of an eye at the beginning of the universe's history. The degenerate era, the time of the corpses, will last far, far longer. In this dark future, strange things will begin to happen in the silent streets of IC 1101. Without the light of stars to push back, gravity will become the only game in town. The stellar remnants will interact. Occasionally, 2 white dwarfs will spiral together and collide, exploding in a Type Ia supernova. These will be the only flashes of light in the darkness, occurring perhaps once every few centuries. Brief fireworks in a city of the dead. Neutron stars will merge, sending ripples of gravitational waves through the silent galaxy. And the black holes. They will be hunting. The supermassive black hole at the center of IC 1101, the beast of 50 billion solar masses, will still be there. It will be waiting. Over eons, dynamical friction will cause the lighter objects, the white dwarfs and neutron stars, to migrate outward to the halo, while the heavier objects sink toward the center. The black hole will occasionally swallow a wanderer, flaring to life for a moment before returning to its slumber. But mostly, it will just sit there, the king of a ruined castle. There is a concept in astrophysics called the heat death of the universe. It is the idea that eventually all energy differences will be smoothed out. Everything will reach the same temperature. No work can be done. Life becomes impossible. IC 1101 gives us a front row seat to this process. It is a microcosm of the ultimate fate of the cosmos. It grew big by eating its neighbors. It burned bright. And now it is cooling. It is a giant engine that is running out of steam. I want you to try to imagine the timescale of 100 trillion years. It is a number that breaks the brain. If the entire current age of the universe, 13.8 billion years, was compressed into a single second, then 100 trillion years would be about 2 hours. We are living in the very first second of the movie. We haven't even seen the opening credits yet. The history of IC 1101 and the history of the universe is overwhelmingly a history of darkness. We are just lucky enough to be alive in the brief flash of light at the beginning. When we look at IC 1101 through our telescopes, we are seeing it in its golden years. It looks stable, but that stability is an illusion created by our short attention spans. In reality, it is teetering on the edge of the abyss. The fuel gauge is on empty. The engine is sputtering. The great, brutal giant is dying. But even dead stars are not eternal. Matter itself may not be eternal. In the far, far future, time scales so long that scientific notation becomes ridiculous. The white dwarfs themselves will fade. They will cool until they stop emitting any heat at all. They will become black dwarfs, cold, dark crystal spheres of degenerate matter drifting in the void. A white dwarf takes about 1 quadrillion years to cool to this state. That is a 1 followed by 15 zeros. That is the time it takes for the graveyard to freeze over completely. And then things get even stranger. Some theories of particle physics suggest that protons, the building blocks of atoms, the things that make up you, me, the stars, and the galaxy, are not stable. They predict that over immense timescales, protons will decay. If this is true, then IC 1101 is destined to literally dissolve. The black dwarfs, the neutron stars, the planets, they will all slowly crumble into radiation and subatomic particles. The physical substance of the galaxy will evaporate. This is the ultimate tragedy of the giant. It spent billions of years accumulating mass, fighting gravity, building a structure of 100 trillion stars. It won the game of galactic cannibalism. It became the biggest thing in the universe. And in the end, it will not leave even a corpse behind. It will vanish like mist. However, before that final dissolution, there is one last player that will remain, the black holes. When all the stars are gone, when the matter has decayed or been flung into the void, the supermassive black holes will be the last structures standing. The monster at the heart of IC 1101 will outlive its host galaxy by an eternity. In the next chapter, we are going to confront the black hole era. We will look at the unimaginable timescales of Hawking radiation. We will answer the question, how long does it take for a black hole the size of a solar system to evaporate? And we will see that even the darkness itself has an expiration date. There is a comfort in the idea of permanence. We look at the mountains and think they are forever. We look at the pyramids and call them eternal. We look at the black hole at the center of IC 1101, that 40 billion solar mass monster, and we imagine it as the ultimate, indestructible object, a scar on the fabric of reality that will never heal. It sits there, hoarding gravity, swallowing light, defying the laws of destruction. Surely, if anything in the universe is immortal, it is a supermassive black hole. But the universe is a place of cruel and absolute mathematics, and the math says nothing is free. Even monsters have to pay their debts. Even the blackest, densest, most terrifying objects in existence are slowly, agonizingly bleeding to death. This chapter is about the end of the end. It is about the black hole era, a span of time so vast that it makes the life of stars look like a single tick of a clock. It is about the process of Hawking radiation, the slow evaporation of the giants, and the final lonely pop that will mark the true death of IC 1101. I am Theodore, the researcher. We have watched the galaxy form, we have watched it eat its neighbors, and we have watched its stars die. Now, we are watching the darkness itself dissolve. If you want to follow this cosmic journey to its absolute conclusion, past the end of time as we know it, please subscribe to the channel. Let us sit together at the end of the universe and watch the last lights go out. To understand the fate of the black hole, we have to understand that black is a bit of a misnomer. For a long time, classical physics told us that black holes were perfect traps. Anything that crossed the event horizon was gone forever. Nothing could escape, not even light. They were one-way doors to oblivion. But in the 1970s, a physicist named Stephen Hawking looked at black holes through the lens of quantum mechanics, and he found a loophole. He found that the vacuum of space is not empty. It is seething with energy. In the weird world of the quantum, pairs of virtual particles are constantly popping into existence. A particle and an antiparticle appear, borrow a tiny bit of energy from the vacuum, snap together, annihilate each other, and vanish. This happens everywhere, all the time. It is the quantum foam that underlies reality. But when this happens right on the edge of a black hole, right at the event horizon, something strange occurs. Imagine a pair of particles popping into existence. One is just outside the boundary, the other is just inside. The one inside is trapped. It cannot escape. It falls toward the singularity. But the one outside, it is still free. If it has enough energy, it can fly away into the universe. It becomes a real particle. But remember, nature keeps a strict balance sheet. You cannot create something from nothing. The energy to create that escaping particle has to come from somewhere. It comes from the black hole itself. The particle that fell in has negative energy relative to the outside universe. When the black hole swallows it, it loses a tiny, infinitesimal amount of mass. This is Hawking radiation. It means that black holes are not perfectly black. They glow. They emit a faint, cold radiation. They are leaking, and because they are leaking, they are shrinking. It is a process of unimaginable slowness. For a black hole the size of the one in IC 1101, the temperature of this radiation is so low that it is practically absolute zero. It is far colder than the cosmic microwave background radiation that fills the universe today. Right now, the black hole is actually absorbing more energy from the background radiation than it is losing through Hawking radiation. It is still growing, even without eating stars. But the universe is expanding. The background radiation is cooling. Eventually, in the deep, deep future, the universe will be colder than the black hole. And on that day, the evaporation will truly begin. Let us try to wrap our minds around the time scale of this death. The larger a black hole is, the colder it is, and the slower it evaporates. A black hole the mass of our sun would take about 10 to the power of 67 years to evaporate. That is a 1 followed by 67 zeros. But the monster in IC 1101, it is billions of times more massive. Its lifetime is calculated in Google years. A Google is 10 to the power of 100. A 1 followed by 100 zeros. Write it down. 1, 0, 0, 0. Keep going until you fill a page. That number is not just big, it is offensive. It renders everything else irrelevant. The age of the stars, that brief, shiny period where galaxies produce light, lasts for maybe 100 trillion years. That is 10 to the power of 14. Compare 14 zeros to 100 zeros. The difference is not linear, it is exponential. The era of stars is a flashbulb going off at the beginning of a movie that lasts for 1 billion years. The universe will spend almost all of its existence in the black hole era. It will be a dark, empty place, populated only by these isolated, slowly dying giants. In this distant future, IC 1101 will be gone. The stars will have decayed or been flung into the void. The dark matter halo may have unraveled. All that will remain is the singularity, a solitary point of infinite density, containing the mass of 50 billion suns, floating in a universe that has expanded so much that the nearest object is effectively infinitely far away. It will be the loneliest object that has ever existed, and it will sit there for eons upon eons, slowly dripping particles into the void. Drip, drip, drip. One quantum penny at a time, paying back the massive debt of energy it stole during its life. The patience of this process is terrifying. Civilizations could rise and fall in the time it takes for the black hole to lose the mass of a single atom. Entire evolutionary histories could play out in the blink of an eye compared to the lifespan of this beast. It is a form of existence that is closer to non-existence. It is a statue carved from gravity, enduring the erosion of eternity. And yet, it is dynamic. It is changing. It is dying. As a black hole shrinks, it gets hotter. It radiates faster. For most of its life, the evaporation is imperceptible. But as it gets smaller, when it shrinks down to the size of a mountain, then a rock, then a molecule, it becomes unstable. The radiation ramps up. It goes from a cold glow to a blinding white heat. The final moments of the monster of IC 1101 will not be quiet. After a Google years of silence, the black hole will scream. In the last fraction of a second of its life, it will release all the remaining energy in a violent explosion, a burst of hard gamma rays that will light up the dark universe for one brief instant. It is a final death rattle, a last assertion of existence before the end. And then, nothing. The singularity will be gone. The event horizon will vanish. The gravity well will flatten out. The 50 billion solar masses that once made up the king of the Abel 2029 cluster will have been converted into a thin mist of particles and radiation, spreading out into the ever-expanding void. The information that fell into the black hole, the record of the stars it ate, the galaxies it consumed, the gas it swallowed, will be scrambled and returned to the universe in a useless, chaotic form. The slate will be wiped clean. This is the ultimate fate of IC 1101. It is not to rule forever. It is to evaporate. It is to turn into light and heat and then fade away. The largest structure we have ever discovered, the most brutal accumulation of matter in the cosmos, is temporary. It is just a phase. When the last black hole evaporates, the universe will enter the dark era. No stars, no black holes, just a soup of photons, neutrinos, and electrons, getting farther and farther apart as space expands. The universe will reach a state of maximum entropy. No work can be done. Nothing can change. Time itself will cease to have meaning because there will be no events to mark its passage. It will be a timeless, changeless, empty void. There is a profound melancholy in this realization. We want the universe to be a story that goes somewhere. We want a climax. We want a resolution. But the physics suggests that the story ends with a fade to black. It suggests that complexity, the existence of stars, planets, and life, is just a temporary fluctuation, a rare accident between the chaos of the Big Bang and the stillness of the heat death. We are the anomaly. IC 1101 is the anomaly. The natural state of the universe is emptiness. But I choose to find a strange beauty in this. If the universe is destined to be empty for eternity, then the fact that it is full right now is a miracle. The fact that we are here in this brief, shiny interval, looking at a monster like IQ 1101, is a privilege. We are the witnesses. We are the eyes of the cosmos, open for a split second to marvel at the grandeur before the long sleep begins. The black hole at the center of IC 1101 will endure for a Google years, but it will never know it exists. It will never wonder about its own size. It will never feel awe. We can do those things. Our lives are short, yes. Our civilizations are fragile. But we possess the capacity to understand the eternal. We can hold the concept of a Google years in our minds, even if we cannot truly grasp it. The evaporation of IC 1101 is the final act of cosmic justice, Gravity gathered everything together. It hoarded the matter. It crushed the stars. But Hawking radiation sets it free. It takes the hoard and redistributes it back to the vacuum. It ensures that nothing is trapped forever. It is a cycle of creation and destruction, of gathering and scattering that plays out on the largest possible canvas. The monster is not a villain. It is a battery. It stored the energy of the cluster for an eon, and in the end, it will give it all back. So, when we look at that smudge in the constellation Virgo, we are looking at a future explosion. We are looking at a battery that is charging up, waiting for the era when the lights go out, waiting to become the last heat source in a dying world. It is a tragic figure, a lonely king sitting on a melting throne. But we are getting ahead of ourselves. We have traveled to the end of time, but we have skipped over the most important question for us, the living. We know IC 1101 is big. We know it is old. We know it is dying. But is it dead? Or is there something, or someone, looking back at us from within that golden fog? In the next chapter, we are going to return to the present. We are going to look for life. We are going to ask the question, in a galaxy of 100 trillion stars, what are the odds that we are alone? We will explore the habitability of elliptical galaxies. We will look at the radiation environment, the lack of new planets, and the terrifying density of the core. We will ask if IC 1101 is a paradise for super civilizations, or a sterile, radioactive wasteland where life never stood a chance. When we look at the numbers, the conclusion seems obvious. It seems inevitable. IC 1101 contains 100 trillion stars. 100 trillion. That is a number so large that if every single human being who has ever lived on Earth was given their own personal star, we would still have 99 trillion stars left over. It is a cornucopia of energy. And in our desperation to not be alone, we look at that number and we do the math of hope. We say, if only one star in a billion has a planet, and only one in a billion of those planets has life, there must be thousands of civilizations in that monster. We imagine it as a bustling metropolis of the cosmos, a Star Wars galaxy filled with trade, war, empires, and voices. We imagine a federation of worlds spanning 6 million light years. But the universe is not a democracy, and it does not care about our statistics. It cares about physics. It cares about radiation. It cares about the brutal, grinding reality of what happens when you pack that many stars into a single gravitational well. And when we strip away the romance and look at the environment of IC 1101 honestly, the picture changes. It shifts from a crowded city to something far more ominous. It starts to look less like a home and more like a tomb. I am Theodore, the researcher, and today we are asking the most dangerous question in science. Is there anyone looking back? We are going to explore the habitability of the largest galaxy in the universe, and we are going to discover that in the realm of the giants, life might be the rarest thing of all. If you want to know if we are alone in the dark, please subscribe to the channel. Let us search for a pulse in the heart of the beast. To understand if life can exist in IC 1101, we first have to understand why we exist here in the Milky Way. We live in a spiral galaxy. Spirals are the suburbs of the universe. They are flat, organized, and relatively quiet. Our sun lives in the Orion Arm, a nice, calm neighborhood far away from the chaotic center. We have plenty of heavy elements, carbon, oxygen, iron, created by previous generations of stars. We are safe from the deadly radiation of the galactic core. We are in the galactic habitable zone, the Goldilocks region, where conditions are just right. IC 1101 is not a suburb. It is a megacity that has grown without zoning laws. It is an elliptical galaxy, a three-dimensional blob of stars swarming in random orbits like angry hornets. And this structure creates problems for life from the very beginning. The first problem is density. In the core of IC 1101, stars are packed together so tightly that the average distance between them might be only a few light weeks, or even less. Compare that to the 4 light years between us and Proxima Centauri. In that environment, the night sky would not be dark. It would be blazing with the light of thousands of nearby suns. A planet orbiting a star in the core would never experience night. It would be bathed in perpetual daylight, bombarded by radiation from every direction. But light is not the killer. Gravity is. In such a crowded environment, stars pass close to each other frequently. These flybys are catastrophic for planetary systems. If a star passes too close to our sun, its gravity could destabilize the orbits of the planets. Earth could be flung out of the solar system, sent drifting into the frozen void as a rogue planet. Or it could be sent diving into the sun. In the core of IC 1101, planetary systems would be constantly disrupted. There is no stability. A planet might spend 100 million years evolving life, only to be ripped from its orbit by a passing neighbor and sterilized. Life needs time. It needs stability. The core of IC 1101 is a blender. But Theodore, you might ask, what about the outskirts? What about the halo? IC 1101 is huge, surely far away from the chaotic center. In the quiet outer reaches of the galaxy, there are stars that are safe. This brings us to the second problem, chemistry. You are made of star stuff. The carbon in your cells, the oxygen in your lungs, the calcium in your bones, all of it was forged in the hearts of stars that exploded long ago. We call these heavy elements metals. For life to exist, you need a metal-rich environment. You need a cloud of gas that has been polluted by the ashes of dead stars. The Milky Way is a star-forming machine. It is constantly recycling gas, enriching it with metals, and making new stars. Our sun is a third-generation star, rich in the ingredients needed to build rocky planets like Earth. But IC 1101 is red and dead. It stopped making new stars billions of years ago. The stars that live there now are ancient. They formed when the universe was young, before there were many metals around. They are metal poor. This means that the gas clouds that formed them were mostly hydrogen and helium. They did not have enough dust to form rocky planets. So, if you flew a spaceship to the outer halo of IC 1101, you would find billions of stars, but you might not find any Earths. You might find gas giants, big balls of hydrogen and helium orbiting their stars, but no rocks, no water, no silicon, no place for life to stand. It is a sterile expanse, a galaxy of ghosts. It is possible that IC 1101 contains 100 trillion stars and almost 0 terrestrial planets. It is a terrifying thought. The biggest house in the neighborhood might be completely unfurnished. But let us play devil's advocate. Let us assume that in a system of 100 trillion stars, probability wins. Let us assume that somewhere, perhaps in a smaller galaxy that IC 1108 recently, there was a metal-rich cloud. Let us assume that there are rocky planets, maybe even billions of them, and let us assume that life found a way. What would that civilization look like? Here, the age of IC 1101 becomes a factor. This galaxy is old. Its stars are ancient. If life evolved there, it could have done so billions of years before Earth was even formed. We are the new kids on the block. A civilization in IC 1101 could have a head start of 5 billion years on us. Think about how much humanity has progressed in just 10,000 years of history, from stone tools to quantum computers. Now, imagine 5 billion years of progress. We cannot even conceive of it. They would be gods to us. According to the Kardashev scale, a Type 1 civilization harnesses the energy of its planet. We are not even Type 1 yet. A Type 2 civilization harnesses the energy of its star. A Type 3 civilization harnesses the energy of its entire galaxy. If there is life in IC 1101, it should be Type 3. It has had the time. It has the resources. A Type 3 civilization would be visible to us. We would see their engineering. We would see stars being enclosed in Dyson spheres to capture their energy. We would see the galaxy glowing in the infrared spectrum from the waste heat of their industry. We would see order imposed on the chaos. But when we look at IC 1101, we see nothing. We see a natural chaotic distribution of stars. We see natural gas. We see a natural black hole. We see no sign of engineering, no sign of megastructures. The galaxy is silent. This is the Fermi paradox written on the largest possible screen. If the universe creates life, and if life naturally expands, then IC 1101 should be teeming with it. It should be lit up like a Christmas tree of technology. The fact that it looks like a dead rock implies one of two things. Either intelligent life is impossibly rare, effectively zero, or civilizations destroy themselves before they can take over a galaxy. Maybe the environment is too hostile. Maybe the active periods of the black hole, when it was blasting jets of radiation through the galaxy, sterilized every world that tried to rise. Maybe the repeated mergers, the crashing of galaxy into galaxy, reset the clock of evolution over and over again. Or maybe there is a limit to how big a society can get. This brings us to the tyranny of distance. We dream of a galactic empire. We imagine a unified government ruling over the stars. But in IC 1101, that is a physical impossibility. The galaxy is 6 million light-years wide. The speed of light is the ultimate speed limit. If the emperor sits on a planet on one side of the galaxy and sends a message to a governor on the other side, it takes 6 million years to get there. 6 million years. In that time, the human species evolved from apes to astronauts. The empire would rise, fall, be forgotten, and be rediscovered as archaeology before the message even arrived. Hello takes an epoch. How are you? Takes an era. No civilization can maintain cohesion across that distance. There can be no trade, no war, no culture. If IC 1101 has life, it is not a unified entity. It is a collection of isolated islands. Thousands of civilizations could exist in that galaxy right now, separated by such vast gulfs of space and time that they will never, ever know about each other. They are trapped in their own little bubbles of light, surrounded by a dark ocean that takes millions of years to cross. They are as alone as we are. Imagine living on a world inside IC 1101. Your view of the universe would be fundamentally different from ours. We look out and see the cosmos. We see other galaxies. We see the structure of the universe. But for an observer deep inside IC 1101, the galaxy is everything. The stars of the galaxy would surround you in a sphere of light. The sheer thickness of the star field would block your view of the outside world. You might not know that other galaxies exist. You might not know about the expansion of the universe. You would think that your ball of stars was the entirety of creation. Philosophy would be different there. Religion would be different. Science would be harder. Without the view of the receding galaxies, they might never discover the Big Bang. They might believe in a steady-state universe, eternal and unchanging. They would be trapped in a golden cage, blinded by the light of their own home. It is a claustrophobic thought to be the king of the universe, but to be blind to everything outside your own castle walls. And there is something even sadder. We talked about the future isolation of IC 1101 due to dark energy. As the universe expands, the other galaxies in the cluster will move away. Eventually, IC 1101 will be the only thing visible in the sky. If a civilization arises in that distant future, they will be truly alone. They will have no neighbors to wonder about, no Andromeda to look at, just their own dying stars and the endless black void. They will conclude that they are the only things that exist, and they will be wrong, but they will have no way to prove it. This is the tragedy of the giant. It is too big for its own good. It is a prison of scale. The distances are too great for connection. The gravity is too strong for stability. The time is too late for vitality. IC 1101 is a monument to the limits of life. It shows us that bigger is not better. The Milky Way, with its fragile spiral arms, its quiet neighborhoods, its mix of generations, is a cradle. IC 1101 is a mausoleum. So, when we ask, are we alone? Looking at IC 1101 does not give us hope. It gives us a reality check. It tells us that the conditions for life are fragile, that the universe is mostly hostile, that Goldilocks zones apply to galaxies just as much as they apply to planets. We are lucky. We are incredibly, improbably lucky to be here in this quiet suburb at this specific time, with this specific view. We should not envy the giant. We should pity it. But the story of IC 1101 is not just about what is inside it. It is also about where it is going. Because even a monster this size is not stationary. It is moving. The entire Abell 2029 cluster is moving. We are moving. Everything is flowing like a river. In the next chapter, we are going to zoom out to the largest scale possible. We are going to look at the cosmic flows. We are going to meet the great attractor and the supercluster, known as Laniakea. We will find out that IC 1101 is just a droplet in a much larger river of gravity, a river that is flowing toward a mysterious destination that we cannot see. Where is the monster going? And what is pulling it there? If you are sitting down right now, you probably feel still. The ground beneath your feet feels solid. The air in the room is calm, and the world seems to be at rest. But this is the greatest illusion that your senses have ever constructed. In reality, you are a passenger on a vehicle that is careening through the dark at speeds that would disintegrate a human body if we were not shielded by the vacuum of space. The Earth is spinning at 1,000 miles per hour. It orbits the Sun at 67,000 miles per hour. The Sun orbits the center of the Milky Way at 500,000 miles per hour. But even that is just the local traffic. If you zoom out, if you look at the galaxy as a whole, we are falling. The entire Milky Way, along with Andromeda and the rest of our local group, is rushing through the universe at over 1.3 million miles per hour. We are being pulled. Something massive, something terrified and hidden behind the dust of our own galaxy, is dragging us across the cosmos. We are caught in a current. And IC 1101, the monster we have been studying, is not just a static island. It is a boulder in a different part of this same rushing river. To understand the giant, we have to understand the flow. We have to look at the map of the universe not as a collection of dots, but as a map of currents, watersheds, and gravitational oceans. I am Theodore, the researcher, and we are zooming out to the largest scale that the human mind can comprehend. We are leaving the galaxy behind to look at the structure of the universe itself. If you want to know where we are going and what is pulling us there, please subscribe to the channel. Let us chart the currents of the cosmos. For most of history, astronomers treated galaxies like islands. They were isolated points of light, separated by vast distances, minding their own business. But in the last few decades, we have realized that this is wrong. The universe is not an archipelago. It is a fluid. It behaves like a liquid. Gravity binds galaxies together into groups, groups into clusters, and clusters into superclusters. These structures are not static. They are flowing. Imagine a landscape of hills and valleys. In this landscape, gravity is the slope. Matter flows downhill, away from the empty voids, the hills, and toward the dense clusters, the valleys. Our Milky Way is part of a flow that is heading toward a region of space known as the Great Attractor. This was a mystery for decades. Astronomers measured the redshift of galaxies and found that everything in our part of the universe was streaming in one direction, toward the constellations of Hydra and Centaurus. But when they looked there, they saw nothing. They saw dust. The disk of our own Milky Way was blocking the view. It was called the zone of avoidance. It was a blind spot in the sky, covering 20% of our view. We knew something huge was back there, pulling on us with the force of a quadrillion suns, but we could not see it. It was like feeling the tug of a riptide, but being unable to see the ocean. Only recently, with radio telescopes that can see through the dust, have we mapped what lies beyond. We found a massive accumulation of galaxies, a supercluster known as the Norma cluster, but even that was not big enough to explain the speed of our fall. We looked further, behind the Great Attractor, and found an even bigger monster, the Shapley supercluster. This is the most massive concentration of galaxies in our nearby universe. It is a titan. It contains tens of thousands of galaxies, a gravitational basin so deep that it is pulling in everything for hundreds of millions of light years. We are falling toward Shapley. We will never get there. Dark energy will see to that. But the river of gravity is flowing that way. This realization led to a new map of the universe. We stopped drawing lines around groups of galaxies based on where they were, and started drawing lines based on where they were going. Just as a geographer maps the watersheds of continents, defining the Amazon basin by where the water flows, astronomers map the basins of attraction of the universe. In 2014, a team of scientists defined our home basin. They named it Laniakea. It is a Hawaiian word that means immeasurable heaven. Laniakea is our supercluster. It is 520 million light-years across. It contains 100,000 galaxies and the mass of 100 quadrillion suns. The Milky Way is just a speck on the outskirts of Laniakea, a tiny stream flowing toward the Great Attractor at the center. Now, where does IC 1101 fit into this? IC 1101 is located about 1 billion light-years away. This puts it outside of Laniakea. It is in a different watershed. It is the king of a different continent. While we flow toward the Great Attractor, the galaxies near IC 1101 are flowing toward it. IC 1101 is the Great Attractor of its own region. It sits at the bottom of the Abel 2029 cluster, which is the density peak of a massive wall of galaxies. It is the drain where all the local rivers meet. This gives us a terrifying sense of scale. Laniakea is huge. It is immeasurable. But IC 1101 dominates a region that rivals it. The universe is a patchwork of these giant basins. Laniakea, the Perseus-Pisces supercluster, the Coma supercluster, the Shapley supercluster. These are the continents of the cosmos, and they are all interconnected by the filaments of the cosmic web. IC 1101 is a node. It is a junction point where the filaments are thickest, a city built at the confluence of great rivers. But there is a conflict in this flow, a war between two fundamental forces. Gravity is trying to pull everything together. It wants to drain the basins, to pull the galaxies into the clusters, to merge Laniakea into a single ball. It wants to turn the universe into a collection of black holes. But dark energy is pushing back. It is stretching the space between the basins. It is widening the valleys and making the hills steeper. Right now, we are in a stalemate. The flows are still moving, the rivers are still running, but the expansion is winning. The distance between Laniakea and the home supercluster of IC Loton is increasing. The space is stretching faster than the gravity can bridge it. We are drifting apart. The map of the universe is being torn into pieces. In the far future, each of these superclusters will become an island universe. Laniakea will collapse into itself, merging into a single giant galaxy, a super Milkomeda. The cluster around IC 1101 will do the same, collapsing into the monster to make it even bigger. But the bridge between us, the filaments connecting Laniakea to IC 1101, they will snap, the flow will stop, the river will run dry. We will no longer be able to see IC 1101. It will be carried away by the expansion, moving beyond the cosmic horizon. The universe will be fragmented into disconnected pockets of matter, each unaware of the others. This concept of cosmic flow changes how we view IC 1101. It is not just a big object. It is a dynamic engine. It is the result of a flow that has been running for 13 billion years. It is what happens when you open the drain. The matter of the universe, the hydrogen, the helium, the dark matter, has been pouring down the gravitational slopes, gathering speed, swirling around the center, and piling up to create this 6 million light-year-wide beast. IC 1101 is the accumulation of a cosmic landslide. And there is another player in this game, one that acts as a pusher rather than a puller. We talked about the great attractor pulling us, but recently scientists found something else. Behind us, in the opposite direction, there is a region of space that is incredibly empty. A void. It is called the dipole repeller. It sounds like science fiction, but it is real. Because this region is so empty, it has very little gravity. The regions around it have normal gravity. This creates an imbalance. The dense regions pull on us, and the empty region does not. The effect is that we appear to be repelled by the void. It is pushing us away. So, the Milky Way is being pushed by the dipole repeller and pulled by the Shapley supercluster. We are caught in a cosmic wind. We are surfing a gravitational wave that spans hundreds of millions of light years. IC 1101 exists in a similar environment. It is likely surrounded by its own voids, its own repellers, pushing matter toward it. It is the beneficiary of a cosmic conspiracy to dump as much matter as possible into one place. This large-scale structure, the web of filaments, the voids, the superclusters, is the largest thing we know of. It is the end of the line for geography. Beyond this, on scales of billions of light years, the universe begins to look uniform. It looks the same in every direction. But on the scale of 1 billion light years, it is a complex, beautiful, and terrifying network. And IC 1101 is one of the brightest knots in that net. Thinking about these flows induces a specific kind of vertigo. We are small. Our planet is a speck. Our star is a speck. Our galaxy is a speck. Even our supercluster, Laniakea, is just one basin among millions. And yet, we can map it. We have built telescopes that can see the motion of galaxies across hundreds of millions of light years. We have traced the invisible currents of gravity. We have found the monsters hiding in the dark. This ability to map the flows is perhaps our greatest achievement. We are like ants who have climbed a blade of grass and figured out the geography of the entire continent. We know about the river, we know about the waterfall, we know about the ocean. We know that IC 1101 is a giant rock sitting in the rapids of a distant stream. And we know that the water is rising. The expansion is accelerating. The continents are drifting apart. The story of the universe is a story of separation. It started with a Big Bang, a moment of perfect unity. Since then, it has been expanding, breaking apart, cooling down. Gravity fought a brave rearguard action. It built the galaxies. It built the clusters. It built IC 1101. It tried to hold the pieces together, but it is losing. The flow toward IC 1101 is the last great gasp of gravity before the dark energy takes over completely. It is the last gathering of the tribes. In the next chapter, we are going to pivot. We have looked at the biggest things in the universe. Now, I want to look at the smallest thing in this story, us, the observer. How do we, with our tiny eyes and short lives, actually see these things? We will talk about the deep field. We will look at the most important photograph ever taken and realize that IC 1101 is not unique. We will discover that the universe is teeming with monsters and that every dark patch of sky is hiding a secret. We will discuss the James Webb Space Telescope and the future of looking back. There is a specific kind of fear that comes from staring into the dark. It is an primal instinct, a genetic memory of a time when the night was filled with predators and our only defense was a dying fire. But in astronomy, the darkness is not just an absence of light. It is a challenge. It is a locked door begging to be opened. For most of human history, when we looked at the black spaces between the stars, we assumed they were empty. We assumed that the void was truly void. We thought that if you pointed a telescope at a patch of sky where there were no visible stars, you would see nothing but the endless, terrifying black of the eternal vacuum. But in 1995, a group of astronomers decided to test this assumption. They decided to do something that many of their colleagues thought was a waste of precious time. They decided to stare at nothing. They took the most powerful eye humanity has ever built, the Hubble Space Telescope, and they pointed it at a tiny, unremarkable patch of darkness near the handle of the Big Dipper. It was a piece of sky about the size of a grain of sand held at arm's length. It was empty. It was boring. And they opened the shutter and left it open for 10 consecutive days, letting the faintest trickles of light soak into the sensor. I am Theodore, the researcher, and we are entering the penultimate chapter of our journey. We have explored the monster galaxy, IC 1101. Now, we are going to look at the crowd it lives in. We are going to discover that the universe is not empty. It is suffocatingly full. If you want to understand the true scale of the cosmos, please subscribe to the channel. Let us look through the keyhole and see what is hiding on the other side of the door. The image that came back from that empty patch of sky changed astronomy forever. It is called the Hubble Deep Field. When the data was processed, the black square did not stay black. It exploded with light. In that tiny grain of sand-sized patch of sky, the telescope found 3,000 galaxies. Take a moment to process that. 3,000 island universes, each containing billions or trillions of stars, were hiding in a speck of dark sky that you could cover with your thumb. There were spirals, ellipticals, irregulars. There were orange blobs and blue dots. Some were close. Some were billions of light years away, their light so old that it started its journey before the Earth even existed. The implication of this image was staggering. If you can find 3,000 galaxies in a grain of sand, and if the sky is made of millions of grains of sand, then the universe is not empty. It is wall-to-wall galaxies. It is crowded. Subsequent images, the ultra-deep field, the extreme deep field, pushed even deeper, revealing 5,000, then 10,000 galaxies in even smaller patches. Based on these observations, we now estimate that there are 2 trillion galaxies in the observable universe. 2 trillion. That is 2,000 billion galaxies. Now bring your mind back to IC 1101. We have spent this entire series marveling at its size. We have called it a monster, a giant, a brute. And it is. It is one of the largest single objects we have ever found. But in the context of the deep field, IC 1101 changes. It stops being a unique anomaly and becomes a face in the crowd. It is one of 2 trillion. It is a very big fish, yes, but the ocean is infinite. When you look at the deep field images, you are looking at a core sample of the universe. You are looking through a tunnel of time. The large, bright galaxies are relatively close. The small, faint red smudges are far away, seen as they were when the universe was a toddler. And somewhere in that mix, in thousands of other patches of sky we have not looked at yet, there are other monsters. There are almost certainly other galaxies like IC 1101 out there. Maybe some are even bigger. Maybe there is a galaxy with 200 trillion stars. Maybe there is one that makes Obel 2029 look like a village. The universe is too big for uniqueness. If physics allows something to happen once, like the formation of a 6 million light-year wide galaxy, it almost certainly happens again and again and again. This realization brings a different kind of humility. It is one thing to feel small next to a giant. It is another thing to realize that the giant is also small. IC 1101, for all its majesty, for all its cannibalistic history, for all its 100 trillion stars, is just a speck of dust floating in a room filled with 2 trillion other specks. It is insignificant on the scale of the multiverse. It is just another drop of water in the roaring river of the cosmos. But our vision is getting sharper. The Hubble Deep Field was just the beginning. In late 2021, we launched the James Webb Space Telescope. This instrument is a time machine designed to go even deeper than Hubble. It sees in infrared light, which allows it to peer through the dust clouds that block visible light and to see the most distant, red-shifted galaxies in the universe. James Webb is already returning images that make the Hubble Deep Field look like a blurry sketch. It is finding galaxies that formed just a few 100 million years after the Big Bang. Why does this matter for our story of IC 1101? Because James Webb allows us to see the ancestors of the monsters. We can look back in time and see the baby galaxies, the small, chaotic clumps of gas and stars that would eventually merge to become the giants. We can trace the family tree of the beasts. We can see the proto-clusters forming in the early universe, the seeds of cities like Abel 2029. We are no longer just taking snapshots. We are reconstructing the movie of cosmic history. We are seeing how the sausage is made, and what we see is chaos. The early universe was a violent, messy place. Galaxies grew by colliding. They grew by eating. The universe did not start with majestic spirals and giant ellipticals. It started with wrecks. IC 1101 is the survivor of billions of years of these wrecks. It is the pile of scrap metal left over after the demolition derby, and James Webb is letting us watch the derby in real time. But there is a philosophical angle here that I want to explore. Consider the act of observation itself. Consider the fact that we can do this. We are biological organisms. We are made of soft meat and fragile bones. We evolved on the African savanna to hunt gazelles and avoid leopards. Our eyes are designed to see things a few miles away in a narrow spectrum of visible light that is useful for finding ripe fruit and water. We have no business knowing what a galaxy is. We have no business understanding the redshift of light or the curvature of space-time. And yet, here we are. We built metal eyes that can see for billions of light years. We built silicon brains that can process the data. We have extended our senses to the very edge of the observable universe. When you look at an image of IC 11-1 or the Hubble Deep Field, you are participating in a miracle. You are the universe looking at itself. The light from those distant stars traveled for 1 billion years, dodging dust, crossing voids, suffering the expansion of space, just to end its journey on the retina of your eye or the screen of your phone. That photon died to bring you that information. It gave up its existence to become a signal in your brain. There is a profound connection in that. We are separated from IC 11-1 by an uncrossable gulf of space and time. We will never go there. We will never touch it. But the light touches us. We are physically connected to the monster by the stream of photons that has been flowing between us for an eon. We are part of the same system. We are not outside the aquarium looking in. We are fish in the same tank, just on opposite sides of the glass. The deep field teaches us that the universe is generous. It is generous with matter. It is generous with energy. It is generous with possibility. Every dark patch is a treasure chest. Every void is a lie. If you look deep enough, if you wait long enough, the light will come. It challenges the nihilism that often comes with astronomy. People look at the scale of the universe and say, we are nothing. We are insignificant. And sure, physically, we are. But functionally, we are the only things that matter because we are the only ones who know. IC 11-1 does not know it is big. The black hole does not know it is heavy. The star does not know it is bright. Complexity without consciousness is just mechanics. It is just a rock rolling down a hill. But we are the witnesses. We give the universe meaning by observing it. We are the storytellers. Without us, IC 11-1 is just a collection of atoms. With us, it is a monster, a cannibal, a giant. We give it a name. We give it a narrative. We make it real in a way that physics alone cannot. This brings us to the final question of our journey. We have looked at the galaxy. We have looked at the black hole. We have looked at the cluster. We have looked at the flow. We have looked at the crowd. But what is the connection between that distant giant and you sitting there right now? Is it just intellectual? Is it just a picture on a screen? Or is there a physical, tangible link that binds your body to the body of the beast? In the final chapter, we are going to bring it all home. We are going to talk about stardust. We are going to explore the nucleosynthesis that forged the atoms in your blood and the atoms in the stars of IC 11-1. We are going to realize that we are not just looking at the universe. We are made of it. We are the ash of dead stars reorganized into thinking matter, looking back at our ancestors. The monster is not alien. It is family. We have reached the end of our journey. We have traveled across 1 billion light years of empty space. We have stood before a galaxy that is 6 million light years wide. We have looked into the eye of a black hole that weighs as much as 50 billion suns. We have watched galaxies eat each other watch stars die, and watch the universe itself dissolve into a cold, dark void. It has been a story of overwhelming scale, a story that seems designed to make you feel small. It is easy to look at IC1101 and feel like a mistake. It is easy to look at the numbers, 100 trillion stars versus one human life, and conclude that we are nothing more than biological dust, accidental contamination on a rock that nobody cares about. But if you walk away from this story feeling only insignificant, then I have failed you, because there is one final twist in this narrative. There is one final connection that turns the entire scale of the universe on its head. It is a connection that is not philosophical, not spiritual, but physical. It is written in the geometry of your atoms and the chemistry of your blood. It is the realization that the monster is not out there. The monster is in you, and you are in the monster. I am Theodore, the researcher, and this is the final chapter of our exploration into the biggest galaxy ever discovered. We are going to close the loop. We are going to find the link between the giant in the void and the beating of your own heart. If you have traveled with me this far, if you have faced the abyss and are still looking up, please subscribe to the channel. Let us finish this together. To understand this connection, we have to look at the ingredients of life. Look at your hand. Flex your fingers. Feel the bones underneath the skin. Those bones are made of calcium. The blood pumping through your veins is red because of iron. The air you are breathing right now is oxygen. The DNA that encodes every piece of information about who you are is built on a backbone of carbon. These elements, carbon, oxygen, nitrogen, iron, calcium, are the building blocks of complexity. Without them, there is no biology. Without them, there is no consciousness. But where did they come from? The universe did not start with these elements. When the Big Bang cooled down, the cosmos was simple. It was boring. It was 75% hydrogen, 25% helium, and a tiny trace of lithium. That was it. There was no carbon to make a cell. There was no iron to make blood. There was no oxygen to make water. If the universe had stayed that way, it would have been a sterile, gaseous fog forever. There would be no IC1101. There would be no Earth. There would be no you. So, how did the universe get from simple gas to complex people? It needed a furnace. It needed a place where atoms could be smashed together with enough violence to fuse them into something heavier. It needed stars. Every star in the night sky, every star in the Milky Way, and every one of the 100 trillion stars in IC1101 is a factory. Deep in their cores, under crushing pressure and millions of degrees of heat, they are doing alchemy. They are taking hydrogen atoms and slamming them together to make helium, releasing energy in the process. This is what makes a star shine. It is a nuclear explosion contained by gravity. But for the massive stars, the ones that live fast and die young, hydrogen is just the appetizer. When they run out of hydrogen, they switch fuels. They start crushing helium into carbon and oxygen. Then they crush carbon into neon and magnesium. They climb the periodic table layer by layer, fusing heavier and heavier elements in a desperate attempt to keep the fire burning. They make silicon. They make sulfur. They make calcium. And finally, in the last days of their lives, they make iron. Iron is the ash of stellar burning. It is the end of the line. You cannot get energy from fusing iron. It actually consumes energy. When a massive star builds up a core of iron, the engine stops. The pressure that held the star up against gravity vanishes in an instant. The core collapses. The outer layers crash down at a significant fraction of the speed of light, bounce off the iron core, and explode. This is a supernova. It is one of the most violent events in nature. For a few weeks, a single star outshines its entire galaxy. But the light is not the point. The point is the shrapnel. The explosion blasts all those heavy elements, the carbon, the oxygen, the calcium, the iron, out into the universe. It scatters the ashes of the star across thousands of light years of space. It enriches the galaxy. It pollutes the pristine hydrogen gas with the dust of life. This is where the story becomes personal. About 4.6 billion years ago, in a quiet corner of the Milky Way, a cloud of gas and dust began to collapse. That cloud was not pristine. It was dirty. It was filled with the debris of generations of stars that had lived and died long before. It contained atoms that had been forged in the hearts of blue supergiants. It contained gold and uranium created in the collision of neutron stars. It contained the wreckage of the deep past. As that cloud collapsed, it formed a star, our sun, but the leftovers, the heavier dust that didn't make it into the sun, clumped together to form the planets: Mercury, Venus, Mars, Jupiter, and Earth. The Earth is a ball of stellar waste. It is a collection of heavy atoms that were cooked in a nuclear fire billions of years ago. And when life arose on this planet, it used those materials. It took the carbon for its structure. It took the iron for its blood. It took the calcium for its teeth. This means that you are not effectively from the Earth. You are from the stars. Every atom in your body, except for the hydrogen, was once inside a star. The iron in your right hand might have come from a star that exploded on one side of the galaxy, while the iron in your left hand came from a different star that exploded on the other side. You are a mosaic of cosmic history. You are a walking, talking, thinking collection of nuclear waste. And this brings us back to IC 1101. That monster galaxy is made of the same stuff. Its 100 trillion stars are doing the exact same work. For 13 billion years, the stars of IC 1101 have been fusing hydrogen into helium, helium into carbon, carbon into iron. They have been exploding as supernovae, filling the galaxy with dust. IC 1101 is not just a ball of light. It is a massive chemical refinery. It contains enough carbon to build quadrillions of worlds. It contains enough oxygen to fill the lungs of a universe of creatures. It contains enough iron to build a skyscraper that stretches from here to the edge of the observable cosmos. We are physically connected to that galaxy because we share the same heritage. The laws of physics that govern the fusion in the core of a star in IC 1101 are the same laws that allow your metabolism to function. The light that shines from those distant suns is generated by the same process that warms your face when you walk outside. We are made of the same matter. We are playing the same game. The universe uses the same Lego bricks everywhere. It builds a galaxy here, a planet there, a human here, a bacterium there. But the bricks are identical. This leads to a profound realization. We are not observers of the universe. We are the universe observing itself. We are the part of the cosmos that has woken up. For billions of years, the universe was blind. It was just energy and matter interacting in the dark. Stars formed, galaxies collided, black holes ate gas, but nobody knew, nobody watched, nobody wondered. It was a play without an audience. But then, through a chain of accidents and evolution that we still do not fully understand, the star stuff woke up. The atoms arranged themselves into complex patterns. They formed neurons. They formed brains. They formed eyes. And those eyes looked up. We are the mechanism by which the universe understands itself. When you look at an image of IC 1101, it is not just a human looking at a galaxy. It is the universe looking in a mirror. It is the hydrogen looking at the heavy elements. It is the small looking at the large. This is our glory. We are tiny. We are fragile. We live for a heartbeat, but we are the mind of the cosmos. Without us, without consciousness, whether it is ours or someone else's, IC 1101 does not really exist. I do not mean it physically vanishes. I mean it has no meaning. Size is a concept that requires a mind to conceive it. Big only means something if there is someone to be small. Old only means something if there is someone to measure time. Beautiful only means something if there is an eye to see it. We give the universe its adjectives. We give it its grandeur. IC 1101 is the biggest galaxy we have ever found. It is brutal. It is dead. It is terrifying. But it is also a monument to the potential of matter. It shows us what atoms can do when you give them gravity and time. And we are the other side of that coin. We show what atoms can do when you give them complexity and consciousness. IC 1101 is the triumph of scale. Humanity is the triumph of structure. Both are necessary. Both are miracles. So, the next time you feel overwhelmed by the size of the universe, remember this. The universe is not out there. It is in you. You are a piece of it that has learned to think. You are the way the cosmos knows itself. That black hole in Virgo, it is your cousin. That galaxy drifting in the dark, it is your ancestor, the light from the Big Bang. It is the background noise of your birth. You belong here. You are not an intruder. You are a native of the deep dark. When you go out tonight, or whenever you can see the stars again, look toward the constellation Virgo. You will not see IC 1101 with your eyes. It is too faint, too far, hidden behind the veil of distance. But you know it is there. You know that right now, 1 billion light years away, 100 trillion suns are burning in the silence. You know that a black hole is sleeping in the center of a city of stars. You know that the light from that galaxy is streaming toward you, washing over the earth, touching your skin, even if you cannot feel it. Hold that thought in your mind. Feel the weight of it. Feel the connection. The biggest galaxy in the universe is waiting for you to acknowledge it. It has been waiting for 1 billion years. And now, you know. Now, the circuit is complete. The universe has seen itself. Thank you for taking this journey with me. It has been a long road, from the discovery of a fuzzy blob to the death of the last black hole. We have covered 13 billion years of history and projected a Google years into the future. We have spanned the gap between the atom and the supercluster. I hope that you see the night sky a little differently now. I hope you see it not as a ceiling, but as a home. If this series has sparked something in you, a question, a wonder, a fear, or a hope, please leave a comment below. I read them, and I want to know how the universe looks through your eyes. If you think these stories are worth telling, share this video with someone who needs to look up. And, of course, if you want to keep exploring the mysteries of the cosmos, if you want to find the other monsters hiding in the dark, make sure you are subscribed to the channel. There are 2 trillion galaxies out there. We have only looked at one. We have a lot of work to do. Until next time, this is Theodore, the researcher. Keep looking up. The universe is bigger than your imagination, but it is not bigger than your capacity to wonder.